Hi, my name is Ibrahim J. Ako from BSE 2A, and today I'm going to answer letter V and E in practice problem in Module 4. So, let's go. So, alright, this is the given, which is in letter B, y double prime plus 4y equals to 0. But first, sir, as you can see, my hands looks like this kasi sir, nag-allergy po ako, that's why hindi po ako nakapag-present ng aking video agad-agad. So, ito po nangyari sa kamay ko, allergy po yan, sir. So, back to the topic. Okay. Assume that y is equals to sum a of n x raised to n is a solution, then y prime is equals to sum n a of n x raised to n minus 1, and y double prime is equals to sum of n is equals to 2 raised to infinity n open parenthesis n minus 1 a of n x raised to n minus 2. So in this, okay, we obtain the index of first sum by 2 units to obtain this one, which is sum n is equals to 2 raised to infinity n open parenthesis n minus 1 a of n x, okay, raised to n minus 2 plus 4 sum n is equals to 0 raised to infinity a of n x raised to n is equals to 0. So we obtain we shift the index of first sum by 2 units to obtain this one. Using y double prime and y in equation 1 or in number 1, we get this, which is sum n is equals to 2 raised to infinity n open in parenthesis n minus 1 a of n x raised to n minus 2 plus 4 sum n is equals to 0 raised to infinity a of n x raised to n is equals to 0. So we get this equation right here. Now, we shift the index of first sum by 2 units to obtain this, which is sum n is equals to 0 raised to infinity open in parenthesis n plus 2 times open in parenthesis n plus 1 a of n plus 2 x raised to n plus 4 sum n is equals to 0 raised to infinity n of x plus x raised to n is equals to 0, or sum n is equals to 0 raised to infinity open a parenthesis n plus 2 times n plus 1 a of n plus 2 plus a sub n plus 2 plus 4 a sub n close parenthesis x raised to n is equals to 0. The power series on left is identically equal to 0. Consequently, all of its coefficients are equals to 0. That's why n plus 2 times n plus 1, okay, is a sub n plus 2 plus 4 a sub n is equals to 0 for all n is equals to 0, 1, 2, and so on, or a of n plus 2 is equals to negative 4 all over n plus 1 times n plus 2 an for all n is equals to 0, 1, 2, 3, and so on. Okay, recall that y is equals to sum n is equals to 0 raised to infinity a of n x raised to n is equals to a sub 0 plus a sub 1 t plus a sub 2 t raised to 2 plus so on. In particular, y of 0 is equals to a sub 0 and y prime of 0 is equals to a sub 1. That's why a sub 2 is equals to negative 4 all over 1.2 an, a sub 3 is equals to negative 4 all over 2.3 an, and a sub 4 is equals to negative 4 all over 3.4. a sub 2 is equals to negative 4 all over 3.4 times negative 4 all over 1.2 a sub 0 is equals to 2 raised to 4 all over 4 a sub 0. And the last one is a sub n is equals to negative 4 all over 4.5. A sub 3 is equals to negative 4 all over 4.5 times negative 4 all over 2.3. A sub 1 is equals to 2 raised to 5 all over 2.5 a sub 1. Hence, y is equals to sum n is equals to 0 raised to infinity a of n x raised to n is equals to a sub 0 plus a sub 1 x plus a sub 2 x squared plus so on is equals to a sub 0 plus a sub 1 x plus times negative 4 all over 1.2 a sub 0 x squared plus or times negative 4 all over 2.3 a sub 1 x raised to 3 plus so on is equals to a sub 0 times 1 minus 2 raised to 2 all over 2 x squared plus 2 raised to 4 all over 4 x raised to 4 plus so on plus a sub 1 all over 2 times 2x minus 2 all over 3 all over 3 x raised to 3 plus 2 raised to 5 all over 5 x raised to 5 and so on is equals to a sub 0 times 1 minus 1 all over 2 times 2 t raised to 2 plus 1 all over 4 times 2t raised to 4 and so on plus a sub 1 all over 2 times 2x minus 1 all over 3 times 2x raised to 3 plus so on. That's why we come up with this, which is y is equals to a sub 0 cosine 2x plus a sub 1 all over 2 cosine 2x. So this is the answer for the letter B. Now let's move for the letter E. So in E, this is the given y prime plus 3 times 1 plus x squared y is equals to 0. So using y prime is equals to sum n minus n is equals to 1 raised to infinity n a of n x x raised to n minus 1 and y is equals to sum n is equals to 0 raised to infinity a of n x raised to n. We get this one, which is sum n is equals to 1 raised to infinity n a of n x raised to n minus 1 plus 3 times 1 plus x squared sum n is equals to 0 raised to infinity a of n x raised to n is equals to 0 or sum n minus 1 raised to infinity n a of n x raised to n minus 1 plus 3 sum n is equals to 0 raised to infinity n of x plus a sub n x raised to n plus 3 sum n is equals to 0 raised to infinity a of n x raised to n plus 2 equals to 0, or this one, which is sum n is equals to 0 raised to infinity times n plus 1 n sub n x raised to n plus 3 sum n is equals to 0 raised to infinity n of x a sub n x raised to n plus 3 sum n is equals to 0 raised to infinity n sub n x raised to n plus 2 equals to 0. Now, to obtain the recurrence relation, we equate 0 the coefficient of x raised to n and obtain this one. So a of n times n plus 1 plus 3 a sub n plus 3 a sub n is equals to 2 equals to 0, or a sub n is equals to negative 3 a sub n is equals to all over n plus 4, which is n is equals to 2, 3, and so on. So a sub 2 is equals to negative 3, a sub 0 all over 6, a sub 3 is equals to negative 3 sub 1 all over 7. A sub 4 is equals to negative 3. A sub 2 all over 8 is equals to negative 3 all over 8 times negative 3 all over 6. A sub 0. A sub 6 is equal to negative 3 A sub 4 all over 10. Substituting all this value in sum n is equal to 0 raised to infinity n of n of a of n x raised to n is equals to y, we get y is equals to a sub 0 plus a sub 1 x plus a sub 2 x squared plus a sub 3 x cubed plus a sub 4 x raised to 4 plus so on. And then we get y is equals to a sub 0 plus a sub 1 x minus 3 a sub 0 all over 6 minus or negative 3 a sub 1 all over 7 x cubed plus so on. So this is the answer for letter E problem. And so that's it. Thank you for listening. Keep safe, everyone.